Hi, my name is Byeongil Min, and today I'm gonna introduce my Raspberry Pi project. Build a smart cloud-connected security camera system. The reason I chose this project was simple. I wanted a reliable DIY security solution that works everywhere, even across different networks. Using Raspberry Pi flexibility, I could not only build a motion detection system using Motion Eye, but also security store the footage in my personal OneDrive and access the camera feed remotely with a Tailscale VPN. This project also gave me the perfect chance to improve my skills in networking, Linux system administration, and cloud integration, and I can see what my cat's doing wherever I want. Now let's go with this project connect to the architecture we studied in class. First, the CPU. The Raspberry Pi ARM processor is the brain that runs everything. Motion Eye software are cloned for OneDrive synchronization, Tailscale VPN client, and the underlying Linux OS processes. Without the efficient ARM CPU architecture, multitasking or this service on a lightweight system would not be feasible. Second, the GPU. While we usually think of GPU for gaming, here it is play a critical role. The GPU handles real-time video encoding from the USB webcam, offloading the work from the CPU, keeping the Pi responsive. Third, RAM. The Pi RAMs acts as a buffer for incoming video frame, processing motion event and temporarily caching video file before they are uploaded to OneDrive. Without enough RAM, the system would lag or crash during high activity period. Fourth, input-output peripherals. This project heavily utilized I/O architecture. The USB connected webcam is centered peripheral. Motion Eye listen for signals from the webcam, save file onto local SD card storage, and simultaneously push them to remote cloud storage. Fifth, network components. Networking is crucial. Motion Eye streams the video locally. Tailscale create a secure private mesh network over any internet connection, allowing me to connect remotely without port forwarding. This highlights the importance of the pipe network interface controller and software-defined networking layers. Finally, the file system management is critical. Setting up directory permission properly, mounting OneDrive with rclone, managing cache, and temporary folders. This is a real-world file system architecture in action. Through this project, I got to see firsthand how each piece of the Raspberry Pi architecture contributes to making a work embedded system, from the low-level I/O to high-level network service. So here the step-by-step process I followed to bring the system to my project. First, I installed Motion Eye to my Raspberry Pi, a lightweight surveillance program through the command line, and configured it to recognize the attached USB webcam as the input device. I adjust the resolution, frame rate, and detect sensitivity based on performance testing. After ensuring local video storage worked, I moved to on cloud integration. Uh, I installed rclone, configured OneDrive access via OAuth, and created a mount point where Motion Eye could save capture video directly. To make it automatic, I wrote a custom system service to mount OneDrive at boot. Then came to network setup. I installed Tailscale on the Raspberry Pi, authenticated the device. The verified it appears correctly in my Tailscale dashboard, and also I configured the Tailscale to start automatically at boot by enabling the Tailscale service. This ensures that even after reboot or network change, I can still remotely access to the Pi securely. Finally, I conducted tests across different Wi-Fi networks, like mobile hotspot, my home Wi-Fi, school Wi-Fi, like coffee shop Wi-Fi, like bunch of the other networks, and making sure I could still connect securely to Motion Eye via Tailscale without having recognition routers. I reconfigured router or firewalls. So this is my result. Can you see my cat moving at the video clip? So the system successfully detect motion using the webcam as soon as movement is detected. Motion Eye saves video clips. These video clips are instantly synced to the OneDrive through the mounted workload directory. OneDrive integration works smoothly. Files were viewable and my phone and PC within seconds of being captured. There were no need for manual upload or delay. Remote access using Tailscale was rock solid, no matter which network the Pi was connected to, like home Wi-Fi, coffee shop, or the library or lab, the classroom. I could open Motion Eye Web UI securely with no port forwarding or exposure to the open internet. This effectively turned my Raspberry Pi into a fully mobile cloud sync security camera that works globally without reconfiguration. I also verified that Tailscale encrypted the traffic properly, ensuring privacy and security even on untrusted network. So this is my troubleshootings. First issue was initially Motion Eye refused to save videos. I turned out to the issue was it turned out the issue was file permission. The Pi user did not have right access to the mounted OneDrive directory. I resolved it by using chmod and verifying group ownership. Second issue was Tailscale occasionally failed to reconnect after reboot. I realized that I needed explicit authentication coaching and fixed it by enabling persistent session and re-authenticating manually one last time. Third issue was webcam disconnection. Occasionally, the PyCam would disappear after a restart. Investigating the logs show intermittent USB installation failure. I solved this by setting a rule that wait for the webcam to become unavailable before launching Motion Eye. Every one of these issues taught me a little bit more about Linux system management service. Service dependency ordering and network troubleshooting. Looking back, I learned some powerful lessons through this project. First, don't trust your first success. You need strong automation and monitoring to ensure the system survives real-world conditions like robust and network change. Second, check the log. Every problem leaves clue if you know where to look. Third, VPN like Tailscale make it easy to get remote access. They remove so many layers of the complexity and risk from remote access setup. If I were to improve this project further, I would experiment with adding AI-based motion detection using like TensorFlow or Fargate, or integrate alert system using like Discord or Telegram, like that. Thank you for listening my the presentation, and have a good day.